Hi, my name is Mark Simonello and I'm a Senior Solution Engineer here at SAP. Now today I have responsibility for this building, and recently there have been some reports with some issues with the air conditioning units in the building. Now I suppose I could probably bring in a team of individuals to check the entire building, going room to room, and that would be very disruptive. However, I have a much better way to go about doing this. In the building, we've installed 178 sensors throughout the air ducts that capture periodic information, such as temperature and air pressure. We are capturing the maximum value at 1 data point per hour for both metrics, so there is a lot of data available for analysis. Using SAP HANA, Lumira, and 3D visualization, we can take a look at the building and model the data superseded over a three-dimensional view of the building. By using HANA, the data can be analyzed with sub-second response and provide the necessary representations for analysis integrated with the 3D viewer. We select the model to display, our building in this case, at 210 King Street. Let's look at the building to identify the material that composes the building. You can identify equipment and material codes of the building by clicking on the material types. For instance, mechanical, plumbing, electrical, ductwork. You can also see the internal structure or framing of the building. You can also rotate the model and zoom in as needed. Let's analyze by temperature. First, we establish temperature as our measure for analysis. The system calculates the values and represents them in the three-dimensional model. The larger square ducts conduct more heat, and it probably comes as no surprise that the ducts highlighted in red are hotter than the others, because heat rises. Let's exclude the building structures so that we can display just the ducts. The larger square ducts conduct more heat, the smaller round ducts are slightly more cool. There is one anomaly where the duct is not conveying heat. We can rotate or flip the model and zoom in on the duct. By zooming in, you can identify the actual location of the leak and create a preliminary diagnosis of the condition. To confirm the issue, we're now going to take our three-dimensional model and do a time analysis of the data. We add the time attribute, and then you can see the evolution of heat and airflow over time. Early in the morning, the ducts begin to heat up, and as we progress to noon, we see the system fully operational. If we pause here at 1 p.m., we see there are major differences between one duct and the other ducts. Our duct in question does not heat up. In fact, it shows as being cooler and is nearly 20 degrees cooler than the other ducts on the floor. Resuming the animation, just to double check our model, we can see by nighttime the ducts have become cooler. Now that I have a pretty good idea of what the issue is and have pinpointed the location, I can now go up to the rooftop to inspect the unit in person. I think I understand the problem now. I believe we have an issue with the secondary flow unit over here and probably need to replace that unit. But before I do that, I probably need to review the technical specifications. Now, I can also do that by hauling around the document and this big manual book with me. But what I'd rather do is use my mobile device and pull up the 3D visualization. And the mobile device is much lighter than that big, bulky, heavy manual. So I bring up the viewer and I can model the unit in 3 dimensions. You can rotate the pump, pinching and zooming in to get a better view of an assembly. But the viewer gives you much more capability. You can also add instructions to each drawing and then rotate through the various drawings to see how the pump assembly should be disassembled. Here, instructions are displayed each step of the way. Once I've drilled down to where the pump is completely disassembled, I simply click the play button to replay in reverse and display the reassembly of the unit. In conclusion, there are several points to remember. First, we captured a ton of data and utilized SAP HANA to query that data. The data was represented in Lumira and then superseded into a three-dimensional model to provide a very unique experience and a much more efficient way of analyzing a problem. Once we were able to find the issue, we quickly found the parts necessary to dispatch a technician to make the repair. And we were able to provide that technician with the right tools and direction to make the repair correctly and efficiently. Our issue was diagnosed quickly, and the problem was fixed quickly. This is the advantage of big data analysis with SAP HANA, Lumira, 3D visualization, and SAP Mobile, bringing it all together.